Hi dears, we will discuss the answers for the 1 mark questions, derivation number 1, which I have uploaded the questions earlier. You can refer to the link I will attach in the description box. First question, we will try to factorize the numerator part. Okay, that is, let's combine the first two terms and taking x square as common. So we get x minus 1, and the next two terms we will take 1 as common. So we get x minus 1. So integral the whole by x minus 1 dx. And now we can take x minus 1 as common. The remaining is x square plus 1 the whole by x minus 1 dx. So x minus 1 gets cancelled. The remaining is x square plus 1. We can integrate separately, and the answer for that is x cube by 3 plus x plus c. Question number 2, integral sine power 6x by cos power 8x. Here we can combine sine power 6 and cos power 6 separately and 1 by cos square x separately. This will become tan x, and power we have 6. So tan power 6x, and 1 by cos square we can write it as secant square x dx. We'll try to do by substitution method, taking tan x as t because the derivative will be secant square. Only tan x we are taking. When we differentiate both sides with respect to x, we get secant square x dx. That can be replaced as dt. This as t power 6. So if we take the question as I, so then that will be t power 6 dt. Apply the power rule. It will be t power 7 by 7 plus c. Replacing t as x, it is tan power 7x by 7 plus c is the final answer. Question number 3, integral sine square x minus cos square x by sine square x cos square x dx. We can take it separately, that is sine square x by sine square x cos square x dx, in between minus cos square x by sine square x cos square x dx. So we get sine square gets cancelled in the first term, cos square x gets cancelled in the second term. So 1 by cos square is secant square x. Same way the second term 1 by sine square is cosecant square x. And we know the formula, secant square is tan and cosecant square is minus cot x. So minus of minus, that will become plus. Final answer, tan x plus cot x plus c. Question number 4, integral 2 cos x by 3 sin square x dx. We can take this 2 by 3 outside of the integral. So that becomes, we can take it as I. So 2 by 3, and cos by sin we can combine, make it as cot, and 1 by sin separately. So that will become 2 by 3, integral cos by sin is cot x and 1 by sin is cosecant x. So we know the formula, integral cosecant x cot x is minus cosecant x, and we have 2 by 3 as a product plus c. Question number 5, 3 root x plus 1 by root x dx. This is just the normal integration. We'll apply the power rule. So we can take 3 outside. This is x power half dx plus integral 1 by root x can be written as x power minus half dx. So when we use the power rule, here this will become 3 by 2, and here we can write it as 2 by 3 plus, here minus half plus 1 is half. So 2 into x power half plus c. 3 gets cancelled. So we get 2 into x power 3 by 2 plus 2 into x power half plus c, or you can take 2 root x as common. If you take 2 root x as common, we have x plus 1 plus c. Question number 6, integral e power tan inverse x by 1 plus x square dx. We can do by substitution method, taking tan inverse x as t. When we differentiate both sides with respect to x, we get 1 by 1 plus x square into dx equal to dt. When we replace in the question, it is e power t. Tan inverse x we have replaced as t, and dx by 1 plus x square as dt. And integration of e power t is as it is, and replacing it as x. So it is e power tan inverse x plus c is the final answer. Next question number 7, integral dx by sine square x cos square x. We can make use of the formula, that is, first let us combine the powers. As the powers are same, it is sin x cos x the whole square. Okay, we know the formula to sin x cos x as sin 2x, and we don't have 2 here, so we take it to the right side. When we replace, it is dx by sin 2x by 2 the whole square. We take to the reciprocal, 2 square is 4, we can take it out, and 1 by sine is cosecant, we have power 2, 2x. And cosecant square integration is minus cot x, so minus 4 cot 2x the whole by coefficient of x is 2 plus c. So here this gets cancelled, so we get minus 2 cot 2x plus c. Question number 8, integral x plus cos 6x by 3x square plus sin 6x dx. Let's take the denominator as t, that is, let 3x square plus sin 6x equal to t. When we differentiate both sides with respect to x, so when we apply the power rule, it is 6x plus this is cos 6x, the coefficient of x is 6, so it is in product, the whole into dx equal to dt. So we can take 6 as common, that will become x plus cos 6x dx equal to dt, and taking 6 to the right side, x plus cos 6x into dx equal to dt by 6. So in numerator, in place of x plus cos 6x dx, we can replace it as dt by 6. So 1 by 6 we can take it out, dt by, as we have taken the whole denominator as t, we will replace it here. That will be integration of 1 by t dt is log t, and replacing t in terms of x, that is 1 by 6 log of 3x square plus sin 6x plus c is the final answer. Question number 9, x plus 1 into x plus log x the whole square, the whole by x dx. We will take x plus log x as t. So let x plus log x equal to t. When we differentiate both sides with respect to x, it is an addition. So x is 1, log x is 1 by x, the whole into dx equal to dt. When we take the LCM, this will become x plus 1 by x dx. So here in the question we are replacing x plus 1 by x into dx as dt, x plus log x as t, we have power 2. So that can be written as x plus 1 by x into dx as dt, x plus log x as t, we have power 2. Apply the power rule, it is t cube by 3 plus c. Expressing in terms of x, it is x plus log x the whole cube by 3 plus c is the final answer. Question number 10, integral cos inverse of sin x dx. We'll make use of, like in chapter 2 you would have learned the inverse functions, isn't it? If you can able to change the sin as cos, then inverse and cos gets cancelled, the argument alone we can take and integrate. So here we make use of the complementary angle property, that is sine of 90 minus theta or pi by 2 minus theta is cos theta. Same way, cos of 90 minus theta is sin theta. Okay, that formula we are going to use when we replace cos inverse of, in place of sine, it is cos 90 minus theta. Sorry, here it is x here. So 90 minus x dx. Cos inverse and cos gets cancelled using the property. So 90 minus x, so 90 into integral dx minus x into dx. When we integrate, this will become 90x minus x square by 2 plus c. Question number 11, integral e to e power 2 dx by x log x. We will try to do by substitution method. So question number 11, we will take log x as t. So let log x equal to t. When we differentiate both sides with respect to x, it is 1 by x into dx equal to dt. So replacing dx by x as dt, log x as t. So we get e to e power 2 dx by x as dt, log x as t. So integrating, we get log t and e to e power 2. Replacing t as log x, so log of log x, e and e power 2. When we do the upper and lower limit, so upper limit minus lower limit, log of log e power 2 minus log of log e. So log and e are reciprocal, that gets cancelled here. We are making use of this property. So here log and e, that is value is 1, remaining is 2. So log 2 minus again log and e, we have 1, and we know log 1 value is 0, isn't it? So remaining, the answer is log 2. Question number 12, integral, this is 0 to pi by 4. Okay, I have written as 1 by root 2. This is pi by 4. Sin 2 theta by sin power 4 theta plus cos power 4 theta. What we are going to do is, we will make use of sin 2 theta formula, as well as we will divide each term by cos power 4 theta. Otherwise, we cannot simplify directly. We will take the integral as I. So, integral 0 to pi by 4 to, we are making use of the sin 2 theta formula. 2 sin theta cos theta, and we are dividing by cos power 4 theta to the numerator as well as the denominator. So this is sin power 4 theta. We are dividing it separately. Sin power 4 theta by cos power 4 theta plus cos power 4 theta by cos power 4 theta into d theta. So one cos gets cancelled. Sin by cos we can write it as tan. So 2 tan theta, and we have cos square term, isn't it? That can be written as secant square theta in the numerator. Denominator, power are same, so we can write tan power 4 theta or tan square theta the whole square, and this gets cancelled, so it is 1 into d theta. Let's try to take tan square theta as t. When we differentiate both sides with respect to theta, when we need to apply the power rule, isn't it? 2 into tan theta into tan theta differentiation is secant square theta into d theta equal to dt. So we have the same term, we don't need any modifications, and we can also replace the limits here, or we can express as x and you can do the upper and lower limit. So here theta and t, theta's value is 0 and pi by 4. When you substitute here, tan square 0 is 0 and tan square pi by 4, so tan pi by 4 is 1 square is 1. So I can be written as 0 to 1, 2 tan theta secant square theta into d theta as dt. Tan square theta we have taken as t. This is whole square. So t square plus 1. So this is of the form integral dx by x square plus 1. That is tan inverse t, and we have the limit 0 to 1. Now the upper limit minus lower limit, tan inverse 1 minus tan inverse 0. Tan inverse 1 is pi by 4, tan inverse 0 is 0. So the final answer is pi by 4. Next question number 13, integral 0 to pi by 4, 1 by cos square x plus 4 sin square x dx. So here we will divide it by cos square x, because other than that we don't have any direct property to do. So question number 13, we will take that as I. So I is equal to integral 0 to pi by 4, and we are dividing numerator and denominator with cos square x. So numerator 1 by cos square x, denominator cos square x. Separately we are dividing each term. So cos square x by cos square x, 4 into sin square x by cos square x dx. We know the reciprocal, isn't it? 1 by cos square is secant square. So 0 to pi by 4 secant square x dx. Denominator, here this gets cancelled, and 4 sin square by cos square is tan square x. We will try to do with substitution method, taking tan x as t, because only secant square we have in the numerator. So when we differentiate with respect to x, we get secant square x dx equal to dt, replacing the secant square x dx as dt by 1 plus 4 into tan x is t, power 2 we have. You can replace the limits. So x and t, x is 0 and pi by 4. When we substitute, tan 0 is 0, tan pi by 4 is 1. So this is 0 to 1. So here in denominator it is of the form x square plus a square format, isn't it? But we have the coefficient 4. We will take it that out. So 1 by 4 as in outside the integral. So dt by 4t square, we have taken 4 as common. So t square 1 by 4, or we can write it as 1 by 2 the whole square. This is of the form integral dx by x square plus a square, that is formula 1 by a tan inverse x by a. So here we have in place of a as 1 by 2, x as t. Taking the reciprocals, it is 2 by 4 and we have the limits 0 to 1. Tan inverse 2t and limits 0 to 1. So this gets cancelled, it is 1 by 2. So we have 1 by 2. We'll do the upper and lower limit. Tan inverse 2t, that is 2, minus tan inverse 0. So tan inverse 0 is 0 and we have tan inverse 2. Final answer is 1 by 2 tan inverse 2. Question number 14, integral 0 to 1 by root 2 sin inverse x by 1 minus x square the whole power 3 by 2 dx. So this power 3 by 2, we'll write it as 0 to 1 by root 2 sin inverse x by 1 minus x square into 1 minus x square whole power 1 by 2. So that 1 plus half is 3 by 2 into dx. Let's take sin inverse x as t. When we differentiate with respect to x, we get root of 1 by root of 1 minus x square dx equal to dt. And to find x, we can take inverse to the right side, that will become sin t. And with respect to the limits, so x is 0 and 1 by root 2. When we substitute, sin inverse 0 is 0, sin inverse 1 by root 2 is pi by 4. Now replacing it as integral 0 to pi by 4. We have taken sin inverse x as t. So t by dx by root of 1 minus x square is dt and 1 minus x square, that is 1 minus sin square t. Okay, and we make use of the identity. So 1 minus sin square is cos square, sorry, t by cos square t dt. That can be taken as the reciprocal. So 0 to pi by 4 t into secant square t dt, and here we have product of two functions, so we make use of integral u dv method. Algebraic and trigonometric, using the Eilert rule, algebraic is taken as u, so u is t. With respect to t, if we differentiate 1 into taking this dt to the other side as dt, integral dv is integral secant square t dt, and we know the integration of secant square is tan t. And the formula is integral u dv uv minus integral v du. So here the question we have taken it as I, u is t, v is tan t. So t into tan t and the limits 0 to pi by 4 minus 0 to pi by 4, v is tan and du is dt. Upper and lower limits, so I is equal to pi by 4 into tan pi by 4, 0 into any number is 0, isn't it? Minus integration of tan, either you can write minus log cos t or plus log secant t. So we will use minus log cos, so that minus into minus plus log cos t, and we have the limits 0 to pi by 4. So tan pi by 4 is 1, 1 into pi by 4 is pi by 4, this is 0. Upper and lower limits for the second term, so log cos pi by 4 minus log cos 0. So we get cos pi by 4 as 1 by root 2. So pi by 4 plus log 1 by root 2. Cos 0 is 1. So minus log 1. And we know log 1 is 0. And this can be written as pi by 4 plus log of 1 by root 2. Question number 15. Integral 0 to pi by 4 dx by cos cube x into root 2 sin x sin 2x. We'll make use of the formula sin 2x in terms of tan. So this is 2 tan x by 1 plus tan square x. When we replace, we'll take this as I. So I is equal to integral 0 to pi by 4 dx. This cos cube we can take it to the numerator. So 1 by cos cube as secant cube x, the whole by, already 2 we have, so 2 tan x by 1 plus tan square x into dx. So 1 plus tan square is secant square. Already we have secant cube in the numerator. This root 4 we can take it as 2. We'll take outside of the integral. So we have root tan x into, this is secant square x, isn't it? When we take the square root, it will be secant x. We'll take into the numerator as it is a fraction, secant x dx. Now splitting the secant power 4x as secant square x into secant square x, and for one term we will replace the trigonometric identity. So 1 by 2 integral 0 to pi by 4 secant square, one term as it is, one term as trigonometric identity, and we will make use of the substitution method. So we will take tan x as t, differentiating both sides with respect to with respect to x. So secant square x dx equal to dt. We can also change the limits. So x is 0 to pi by 4. So t tan 0 is 0, tan pi by 4 is 1. So replacing that, I is equal to integral 0 to 1 secant square x dx as dt, and 1 plus tan x is t, so it is 1 plus t square by root t. So this can be written as, like we can split the terms. So integral 0 to 1 by root t or t power minus half, and t power 2 by t power half or 2 minus 1 by 2, that is t power 3 by 2. When we integrate, we get minus half plus 1 is half, so it is 2 root t, and here it is 5 by 2, so 2 by 5 t power 5 by 2, and the limit 0 to 1. As we have changed the limits, we will directly do the upper and lower limits. So 2 into root 1 is 1, 2 into 1 is 2, 1 power positive number 1 into 2 by 5 is 2 by 5, minus product is t, so when we substitute 0 it will become 0. And overall we have this 1 by 2, isn't it? So that we should not forget. So the whole into 1 by 2. When we take the LCM, 5 2s are 10 plus 2, 12 by 5 into 1 by 2 we have outside. So we can cancel this 2 and 12. It is 6 by 5. 16th question, integral 0 to pi e power 2x sine pi by 4 plus x dx. So let's do it by UDV method. Eilert property, trigonometric exponential. So taking sine of pi by 4 plus x as u, when we differentiate with respect to x, it is cos of pi by 4 plus x into dx. Same way, integral dv is integral e power 2x dx, that is v is equal to e power 2x by 2. Using the formula, integral u dv is uv minus integral v du. So here, as we have taken question as I, so I is equal to uv, that is e power 2x into sine of pi by 4 plus x, the whole by 2. We have the limits 0 to pi minus integral 0 to pi. V is e power 2x by 2. Du is cos of pi by 4 plus x dx. We will take this as I1. Here we will do the upper and lower limits. That will become e power 2 pi sine of pi plus pi by 4, the whole by 2, and minus the lower limit e power 0 sine pi by 4 by 2 minus I1. Okay, so pi plus theta, third quadrant, sine is negative. So e power 2 pi minus e power 2 pi sine pi by 4 by 2. E power 0 is 1. Sine pi by 4 is 1 by root 2. Already 2 we have in the denominator. And for I1, 1 by 2 we can take it out. 0 to pi e power 2x cos of pi by 4 plus x into dx. So taking u as again the same properties how we done the first question, like first part. So u as cos of pi by 4 plus x, differentiating both sides with respect to x. So cos is minus sine pi by 4 plus x into dx, and integral dv, it is e power 2x dx. V is equal to e power 2x by 2. Again the formula udv is uv minus integral v du. So I1 can be written as uv, that is e power 2x cos of pi by 4 plus x, the whole by 2, and outside we have 1 by 2. Okay, so that we should not forget. At last we will do minus integral 0 to pi v du, that is e power 2x by 2 minus sine, so this will become plus sine of pi by 4 plus x dx into 1 by 2. We will multiply this 1 by 2 inside. So upper and lower limits we have for this. 0 to pi. So when we apply the limits, upper limit is e power 2 pi cos of pi plus pi by 4, 1 by 2 into 1 by 2 the whole power 4, minus e power 0 cos of pi by 4 by 2, already 1 by 2, so we'll take 1 by 4, here also it is 4, and e power 2x sine of pi by 4 plus x we have taken it as I, we'll substitute as I, and we'll take this as first equation and we'll substitute here. Okay, so sine pi by 4 is 1 by root 2 again. Therefore, the first equation implies I is equal to minus e power 2 pi, this is 1 by root 2, so 2 root 2, minus 1 by 2 root 2, minus of this term, okay. So here cos of pi plus theta, third quadrant cos is negative, cos pi by 4 is 1 by root 2, so it is minus of minus plus e power 2 pi by, we have 4 root 2, e power 0 is 1, cos pi by 4 is 1 by root 2, minus into minus plus 1 by 4 root 2, minus into plus minus 1 by 4 I. We'll take this minus 1 by 4 to the left side. So I plus 1 by 4 I. Here, when we combine these two parts, 4 by root 2 will be the LCM. So e power 2 pi minus 2 into e power 2 pi. So it is minus e power 2 pi minus 1 by root 2 plus 1 by 4 root 2. So we'll multiply with 2, isn't it? Is minus 2 plus 1 minus 1 by 4 root 2. Okay, when we take the LCM here, it is 5 by 4. We'll take to the other side. It is 4 by 5. And we have the LCM 1 by 4 root 2. You can take minus also as common. So 1 plus e power 2 pi. 4 and 4 gets cancelled. So it is minus 1 by 5 root 2 into 1 plus e power 2 pi.